Venus today is no longer seen simply as a stagnant hellscape, but as a dynamic, evolving world whose secrets are only beginning to be revealed. In the past few years, new analyses have reshaped our understanding of its geology, atmosphere, and interior, while a new generation of spacecraft is preparing to probe deeper than ever before. Venus is no longer a silent planet, it is active, mysterious, and ready to be uncovered. Signs of a restless planet. The most striking shift in recent years is the mounting evidence that Venus is still geologically alive. For decades, its volcanoes were assumed to be long dormant, their lava plains carved and abandoned 500 million years ago. But reprocessed radar data has revealed a very different reality. Scientists have identified flows that look fresh, not ancient. Regions like Sif Mons and Niobe Planitia display features consistent with recent eruptions, while vents have widened or collapsed within just months between radar passes. These are not scars from deep history, they are fingerprints of activity happening now. This means Venus is not geologically extinct. Heat from the mantle is still forcing its way upward, reshaping the surface under immense pressure. Alongside this, immense circular formations called coronae, once thought to be ancient relics, show evidence of ongoing activity. Their fractured edges and bulging centers reveal mantle plumes still pressing against the crust. Venus may lack plate tectonics, but it has its own style of surface motion. Researchers describe it as flake tectonics, where the crust fractures into patches that bend and drift under interior heat. Far from frozen in time, Venus is a restless planet whose geology is unfolding today. Mystery in the clouds. Above this active surface lies an atmosphere filled with unresolved puzzles. In 2020, astronomers reported the possible detection of phosphine gas in the upper clouds, an announcement that sent shockwaves through science. On Earth, phosphine is linked to biological processes, sparking speculation about microbes drifting in Venus's skies. The detection has been debated ever since. Some studies support it, others question the signal, but the deeper point remains. Venus's clouds are chemically unusual. At around 50 kilometers above the surface, conditions are surprisingly Earth-like in pressure and temperature, though the environment is far from friendly. The clouds are dominated by sulfuric acid droplets, carried by winds that circle the planet at hurricane speeds. Yet within these clouds, unusual molecules such as phosphine and ammonia have been tentatively observed. Their source is still unknown. They may come from volcanic injections, from exotic atmospheric chemistry, or perhaps from processes we do not yet understand. Even if life is not the answer, the unexplained chemistry itself demands attention. Every droplet and molecule in Venus's skies is a clue, and solving the puzzle will expand our understanding of how atmospheres behave on hostile worlds. Balloons, wings, and floating labs. Studying these clouds requires going inside them. But Venus destroys spacecraft quickly, landers survive only hours before being crushed and scorched. To last longer, engineers are developing new designs capable of floating in the upper atmosphere. One concept, exploring Venus with electrolysis, imagines a balloon that generates buoyant gases directly from carbon dioxide in the air. This would allow it to hover in the skies for months, acting as a mobile laboratory that collects samples and monitors atmospheric changes. Another design is the Venus Atmospheric Maneuverable Platform, VAMP, a semi-buoyant flying wing, gliding through the clouds like a vast manta ray. Powered by sunlight during the day, it could cruise at high altitudes, then drift lower by night to sample different layers. Unlike short-lived probes, VAMP would be a true explorer, traveling across regions and carrying instruments deep into the cloud decks. These platforms could host specialized tools such as the autofluorescence nephelometer, designed to shine light through cloud droplets and measure whether they fluoresce, a potential signal of organic chemistry. With such technology, Venus's skies could be studied directly, offering the first real tests of whether exotic chemistry or even faint traces of biology are present. The next wave of missions. After decades of neglect, Venus is about to enter its most intensive era of exploration. A fleet of major missions from NASA and the European Space Agency will arrive in the 2030s, each designed to answer fundamental questions. NASA's Veritas will orbit Venus with powerful radar, mapping its surface at resolutions down to tens of meters. It will monitor geological changes in real time, track volcanic eruptions, and measure gravity to probe the planet's interior. Meanwhile, Da Vinci Plus will dive directly into the atmosphere. Its descent probe will sample gases and isotopes as it falls, capturing high-resolution images of the rugged Tessera Highlands' ancient terrain that may hold clues to Venus's lost oceans. By the time it reaches the ground, Da Vinci Plus will have revealed whether Venus once had water and how its climate spiraled into catastrophe. The European Space Agency's Envision will join them, combining radar mapping with atmospheric studies. Its mission is to connect geological activity to climate processes, offering a full-system view of Venus as a living planet. Together, these three spacecraft will deliver the most detailed picture of Venus ever achieved. Small probes, big questions. While these flagship missions dominate headlines, smaller projects may deliver equally important insights. The privately funded Venus Life Finder will send a compact probe directly into the atmosphere, targeting the very layers where phosphine was reported. Its goal is simple but profound: to search for organic signatures in the clouds. Other proposals aim to study the surface. The Valkyrie mission envisions scattering a network of small landers across Venus. Each would transmit only briefly, but together could reveal critical variations in temperature, chemistry, and surface conditions. Russia is developing Venera D, pairing a long-lived lander with an orbiter to provide sustained monitoring. China is also considering its own mission concepts, adding to the growing international push to explore Venus. Together, these projects form a diverse strategy: orbiters, descent probes, balloons, and landers, all working to unlock the layers of Venus's mystery. Why Venus matters. Why is Venus suddenly at the center of attention? Because it is our twin and its story holds urgent lessons. Venus and Earth began alike, similar in size, mass, and composition. Yet while Earth nurtured oceans and life, Venus spiraled into disaster. Its water boiled away, its skies filled with carbon dioxide, and its surface became hotter than Mercury's, despite lying farther from the Sun. Studying Venus reveals how climate can transform a planet. It shows us the extreme end of the greenhouse effect, offering insight into tipping points that Earth must avoid. Venus is not just a neighbor, it is a warning. At the same time, the possibility of life in its atmosphere, however slim, would be revolutionary. Even the faintest traces of microbial activity in its clouds would prove that life can persist in environments once thought impossible. Such a discovery would expand the scope of astrobiology and reshape our understanding of the universe. Venus is no longer a silent world hidden behind clouds. It is geologically active, its atmosphere filled with unexplained chemistry, and its story more urgent than ever. In the years ahead, spacecraft will orbit, descend, and drift through its skies, mapping volcanoes, measuring gases, and probing mysteries that may reveal both its past and our future. For the first time, we will see Venus not as an enigma but as a world alive with change. The veil is lifting, and what lies beneath may alter not just how we see Venus but how we see ourselves.